Hello and welcome to this session about AI, machine learning, and especially live demos on how this technology is being used and powered by Adobe Sensei. So, if AI would be as advanced as we predicted in the 90s, and who doesn't know HAL 9000 with the prediction that humans will be replaced by machines, well, then two robots will be presenting the session today. So luckily, we are not there yet, and hence, let me introduce you to Butterfield. He's the mastermind of the AI Forge Adobe Sensei, and he will show us some live demos with AI technology. I am Giancarlo Berner, and I worked in the AI field in the 80s and 90s of last century. Oh gee, that doesn't sound good. So, what will we be covering in this session? We will start with some basic introduction on AI and machine learning. I initially had something like 385 slides with theory and graphics and things. Brett forced me to reduce that to maybe 5 or 6 so that he could show his presentation and his live demo. So we will have you a small walkthrough what is machine learning, the basics of the machine learning styles and algorithms, so that you get a foundation of what Brett will be showing in the live demos. So you get sort of an association to this technology. As I mentioned or indicated before very shyly, AI goes back a long time. And this is a definition about what is artificial intelligence. I gave at a presentation in 1983 where I guess most of you weren't even born yet. So that's maybe the scary part of the thing here. So I divided artificial intelligence in a field of 4 main subjects that is building, defining systems that act like humans, that think like humans, that learn like humans, and that decide or predict like humans. Today I would add and perform tasks like humans, even if these tasks may not be very intelligent. Okay. So actually, AI goes back more than 60 years. So in 1956, there was this AI research workshop, which was the beginning of the AI era. Then we had different areas of AI. The reasoning algorithms, I don't know if you know these old games where you played against machines that was coming up. Natural language processing was very popular. And then the first shy steps of robotics were, and these robotics were used in the manufacturing industries. Then came the era where I joined, as were expert systems, knowledge base, and I was a dreamer, and I believed if you can analyze everything in ones and zeros, well, you can build a system that analyzes everything. And so USA was one of these shy approaches which, to be honest, failed badly. It didn't come out like it should. Then we had this Deep Blue, IBM's Deep Blue chess machine that initiated a new area with autonomous driving, robotics, the speech recognition things were coming up. This goes back to the 90s and early 2000s. Okay. The boom we see today actually happened because we need to deal with big data. Big data got popular. Flat databases, MongoDB, all these things, we had to manage that stuff. And so these machine learning algorithms were getting more and more popular. And this boom is what you see today on the machine learning or artificial intelligence are a lot of these algorithms. Brett is going to show some voice search, speech recognitions, but also some very intelligent indexing of content. And below you see a little bit of the work I did very, very long ago. So if you ask 100 AI researchers how you would quantify or qualify artificial intelligence, you will get 100 answers. This means no one really knows what the whole field consists of. So I'm still using my old structure into 4 segments: act, think, decide and predict, and learn. So you see there are a lot of subjects and fields there, which we could, of course, discuss for the next 12 or 13 hours if you want. They all have their justification and are still popular today. But since Brett is waiting with his live demo, I think we're going to just focus on the basics or foundation of machine learning. So what is machine learning? We hear a lot about it. Machine learning is the science of building systems that continuously improve themselves, not by changing the code or modifying the code, but by processing more and better data. So the machine learning styles I'm going to describe in a moment, they are all around that feeding data to improve the output from a given methodology. And this goes back 35 years, 27 years. Oh, don't mention it. So machine learning styles, we structure them into supervised learning, unsupervised learning, and recently we see this reinforcement training methodologies. These are, I would say, the most popular ones, and a lot of what Brett is doing is going to be around these few styles. So the supervised learning is when you try to train your model with input you know and with the expected output, and you have to try to map these functions so that the model returns the output you expect. And that's how these systems learn. In an unsupervised learning, we don't know the input, we know the input variables or the data we input, but we don't really know the outcome. So these systems, using the unsupervised learning, they're more made for structuring your content structure or, your content model or your data model. And for example, to look for similarities so that you can do more precise predictions. We're going to see 1 or 2 examples using that. And then the newer style is reinforcement training. I like to call it trial and error because the process there is that you try to find the next best action based on an award, based on points. And if it doesn't work out correctly, you repeat it, you do a regression process. So if we look at supervised learning, remember the one where we know what data goes in and we know what data is being expected, we have some categories like classification and regression. So the classification is when you define your data into categories, and you can do things like you have headache as an input variable, and then your prediction should be I'm sick. So your mapping functions should learn that if someone enters headache, you're going to be sick. And that's how you learn, these machines learn, by adding more and more data to being more precise. Expert systems work like this. Regression is when we know the input and the output is real world values. So maybe you saw these systems where you stand in front of something and the machine predicts your age. These are regression systems. Then there's a list of the most popular algorithms. I would say, Google them, or if you work with them, that's another story. The linear regression is very popular, or you see a lot of the naive Bayes. It's coming more and more. It's more and more popular because it's based on past events. So the next event that occurs is based on the past events. So these methodologies or algorithms are quite common, and Brett will actually show 1 or 2 of them. Okay, unsupervised learning, this is more popular among e-commerce solutions or marketing solutions. So there we have associations, clusterings, and dimensionality reduction. So the association is when you predict the outcome of the next step. So for example, you buy a printer, the probability that you buy toner is 85%. So this is how associations work. Then we have the clustering, where the purpose is to group similar objects into samples and distinguish between different clusters of data. And the third, dimensionality reduction, is when you try to reduce the amount of variables, because in the world of big data, you have a lot of dirty data which you don't need. So you try to reduce the amount of variables, but still keep the meaning of the data set or the importance of the data set. Typical known is feature extraction, and I think Brett has even an example on feature extraction. And popular algorithms, the a priori one, you find that a lot in the commerce solutions. Then we have k-means, and k-means is getting more and more popular too because it is an iterative algorithm. The problem there is that it repeats certain steps and the outcomes are not always precise. So you get sometimes this interesting thing when Amazon sends you a recommendation on a product you just bought 3 days ago. And for these who work in the feature extraction or value reduction field, the PCA is very common. I don't think I'm going to ask you if you have any questions, because I'm sure you're all waiting for Brett to show his live demos. So Brett, all up to you. Brett will show you work he's done with Adobe Sensei, the AI forge of Adobe, and enjoy it.
Cool. Nice work. I like these couches. I think the people that got in here early, I encourage that. Get a couch. Come early. Yeah, so I'm Brett Butterfield. I'm a director of engineering on the Sensei team. And just super high level, Sensei is kind of an umbrella term for all of the AI, machine learning in Adobe. It could be targeting ads, improving search results. I'm going to focus on content classification, which you'll kind of see some examples of. I can't really see you guys because these lights are really bright, so I'll just assume you guys are interested. So I'm going to go ahead and I'm going to work with some of the same images in a couple different scenarios, and so you can kind of see how the effects are. So, you know, from this image, as humans, we can say, oh, okay, it's a woman. She's probably in Europe. She's riding her bike with her son on the back. But let's see what our auto tagger sees. So these are the real results from our auto tagger, and you can see some things like bicycle, bike, woman. These are all object-based tagging, which is really, you know, kind of a standard. But what we can also determine is that it's fun, that they're in nature. These are things that aren't necessarily determined inside of the image, but we can actually determine these higher level concepts. Let me just do a couple more just to give you examples. Family. I've never tried to tag this one, so it'll be a surprise. Come on, baby. Yeah, so we got car, family. Again, the higher level concept is happy. They're driving, it's a couple, they've got a child. And you know, what we've done that's really interesting is we've trained our tagger with content from Adobe stock. And so we acquired a company called Fotolia 4 years ago. And in that acquisition, we received about 40 million images that had been hand tagged by photographers. We took those images and those tags, fed them into the neural network, and that's how we're able to get the association of a family that they're happy, because there was that association inside of those tags. And so something really unique to Adobe. We started off with 40 million. I think we're at 130 million, just photos and it's videos and all kinds of other content as well. This one is an evolutionary process. So this was our old tagging model, and you can see that it thought this was a ladybug. So things kind of go downhill from here. It's an insect, it's a ladybug. Not really accurate. With our new model, we switched over to ResNet, which is a higher resolution network, and now we can see that it's fishing and it's a net, and then we get all of these different concepts around fishing. So we continue to improve. What we're doing now is object-based, and so isolating each object. So it would say exactly where the net is, where the buoy is, where the bicycle is. And so not only do we get more specific information, but we can also determine location. This one's kind of fun. Rorschach. Anybody? What do you see? I see two mice giving high fives, but I don't know. That's just me. See what Sensei thinks. And it's abstract. This is possibly blood. It may be. I don't know. It might be Christmas. I'm not sure. But it does get this illustration that's on paper, and that there's love. That's nice. Here, we've kind of gone beyond just tagging of photos. This was released at Adobe Max in the fall. And here what we're doing is tagging videos. And so we're creating a summary. That's my dog, Mochi. He's crazy. We're basically looking at the entire video, taking snapshots of pieces of the video, and then summarizing those into these tags. One thing that Adobe is doing that's really unique is determining actions from the video as well. So we can see here that they're playing. It's a dog and it's on the beach. And so, again, just another way where you can start to understand what's in your content without ever having to open it. So this is more of Adobe research project at this point. But here what we're doing is temporal, so time-based tagging of video. And so here in the pulse mode, you're seeing exactly what tags we're seeing in the video as it's playing. If I switch over to timeline, I can click on here. I can see where the dog is. I can also see where he's swimming. So the idea here is I could be able to ingest all of my content, or my video content, be able to search across both tags and actions, and then find out exactly in the video where that is. And I was like, I need a dog that's swimming, and find all those videos instantly, find the exact point where that happens. And this will be coming out. I can't give any timelines. I work on an innovation team, so what we do is really work with Adobe Research. We get the technologies. I'll tell my team, hey, get this model up online, so let's do an evaluation. If it passes the sanity check, we go in and then we do a full formal evaluation where we put it in front of consumers with a service called Crowdflower, and we say, is this a dog? They're like, yes. Is it swimming? Yes. And then we're like, yes. This is a part of the evolution of this project. Here what we're doing is looking at the entire video and then picking the best frames. And so this would be an automatic thumbnail selector. In this video, the top selection is this first one, which is pretty cool. I agree. This is a project that was I'm trying to include some AEM stuff in here. This project was announced as a sneak. So this is like where the researchers or developers come up with an idea. They pitch the idea. There's usually about 200 to 300 of across the country a company, and then they pick the top 8. And then you go on stage in front of about 15,000 people, 20,000 people. I just did one in the fall in front of 16,000, and I'll show you some of that. It's a little nerve-wracking. This is nothing. But the idea here is that you're creating content. Let me do this real quick. Uh-oh. Doo-doo. Well, I think I just need to do this. Okay. I think we're good. Yeah, so you're taking your content, you're creating it, you want to output it into different formats. And so you might be going to Facebook, you might be going to, this is the Instagram Stories format. And if you're doing it in center crop, you're only going to get this content. What we're doing on the right is we're actually looking for the salient object with a custom model we created that's actually tracking the movement. Here it's in simulation, and it's because of the network, it's a little bit slow and clunky, but it actually works pretty well. Let's try a different example. So yeah, on the left, what you would get with center crop. On the right, what happens when we're actually tracking the object. And I think that they're calling this smart crop, and it's been announced to go into AEM soon. I'm not sure. We're going to close this window. It's not really doing it right now. This project was around, we saw automatic tagging. This is automatic titling of photos. And so the top is the least aggressive, like the most likely that this is accurate, but the least descriptive. The bottom is the most descriptive. So Eiffel Tower in Paris is accurate. Reflection in lake is accurate. Young woman in a bicycle, accurate. Young couple in a car, pretty accurate. Butterfly, flower. This one here, young man in a hat. Young at heart? Not sure. Female hiker in the mountains, that's also a good one. Here, this project was around identifying logos in images. Sometimes, specifically for stock images, we don't want to have logos in the image. So one thing we can do is tell you if there are logos in the image, but we can also help you find logos in the image. So we can say all of the images that have the Netflix logo, and then you would be able to find that content. So it's not only identification, it's identification that can be used for exclusion or inclusion. How does this all work together? So this is actually in production. So what we've done for Adobe Stock contributors is they upload their content. We automatically set the category. So transport in this section. Let's do this one. Come on, network. Yeah, here we go. Yeah, so we automatically set the categories people in this one. We have set the title to Farmer's Daughter, which is probably accurate. And then, this one says car. You can go in, you can change these, you can delete them. Say tractor. Or reorder the order and then submit for approval. And so this is really awesome for professional or non-professional photographers that want to submit large amounts of content. Previously, they would have to fill each of these fields in individually, and now they can just go in, accept the predictions or modify those and hit next. And so this has been massively successful, and it's really cranked up the volume of the content that we're searching across now. Here, this is a facial feature prediction. So we're predicting the age, the gender, and then attributes like glasses, hat, smiling, and their emotions, and even which way they're looking. So, you really can get down to the point where you say, not only are we predicting these attributes, but also the positions. So you can say, I need a woman in her 20s, I want her on the lower right, I want a man in his 30s, I want her to be angry, I want him to be happy, all of these different attributes. I want him in his 30s, and I want him to wear a hat. She's wearing glasses. All of these attributes are available in the predictions. That one's me. 49. All right. Happy, looking down. And then you can see that it didn't pick my dog, Mochi. Actually, can identify humans. This one, I got up really early today, so hopefully Sensei will be nice to me. So this would be on the live feed. Come on, baby. Or not. Anyways, typically we'll do the prediction on the live feed. I'm kind of surprised it's not. Let's check it one more time. Let's see if I'm on the right. Yeah, on the right network. Well, anyways, it's not working right now, but it typically would. I think it probably will if I give it enough time, but I don't want to wait. So this is kind of a good example of a project. I wasn't really tracking my time, so I'll just keep going. This is a typical research project. So researchers, they have a research problem. They say, we want to automatically determine the aesthetics of an image. And part of that is the overall quality or the aesthetics. So this was really high at 94%. But then all of these different elements, like how much depth of field is in the photo, 88%, object emphasis. And then what they do is they complete the project, they write a paper, they file a patent, and then it kind of sits on the shelf. What my team did for a hackathon was we processed 60 million images with these values and then put those in Elasticsearch. And when we put them in Elasticsearch, we created the ability to make them a filter. So you can say, I only want images with this high of an aesthetic value. And this is in production. So if you go to Adobe Stock, here I'm going to say I want images with lots of depth of field. I can also, where is it? Say I really want muted colors. More muted. Yeah, this is kind of cool. If I see something I like, I just drag it up. So now we're going to be doing image similarity plus those different attributes across these. And so once again, we started off with 360,000 butterflies, and then we're able to start isolating the content down based on examples and then based on these different types of filters. Is it cool? Yeah. All right. This is a good example of a project, where it originated from a collaboration with research. And so, yeah, this network is not happening. Who's streaming YouTube? I know one of you guys are doing it. Yeah, so the idea was, we originally just had similarity, and what we wanted to do was be able to isolate those results. I wonder if is this on? Oh, I understand the problem. It's a big problem. Yeah, that's probably why that other one didn't work. Oops. Now you know our VPN endpoint. There we go. Yay. Okay. Cool. So this is just regular similarity, but what we wanted to do was to give the user more control. So here I'm just going to highlight the dog. So now I'm saying I only want the dog. I can invert the mask and say I don't want the dog, I just want the family. We can also combine multiple images. So I'm going to go back over here. We get that bicycle. And then I'm just going to kind of really rough go right over her. So now we're getting, these different families on the beach, with the women on a bicycle. So we've been able to take attributes from the first image and to bring them to the second. But I'm just going to go up here again, and I'm going to say I don't want the family. I just want the beach. And there we go. We took the woman from Amsterdam. Now we got women on bicycles on beaches. Yay! Is it lit? Pumpkin cat. I like a pumpkin cat. This would be Adobe stock results. One thing that we can do that's really unique is we have the ability to not only take different attributes from the image, but we can also use keywords. And so here I can actually say dog. We're not getting the pumpkins. What's going on here? I think it was related to our earlier issue. Let's try again. Okay, so now I'm saying, oh, I screwed up. I'm saying dog. Well, now it's our main image. It's cute. We're saying dog plus the pumpkins, but taking the attributes from the cat. You can also use color. I could just say, I just want to take the colors from this image, and then corn dogs, that's pretty cool, and the keywords. And so this is really valuable. If you're working in Photoshop and you're compositing multiple images, you can upload one and say, I need the colors from this plus the specific keyword, and these images are going to be really easy to composite together. This is our competitor, Shutterstock. I uploaded the cat image. It did okay, I guess. There's no ability to do keywords or colors or anything. So just to kind of give you an idea of where our competitors are at and then the things that we're offering through all of this AI machine learning. This is a tool we created. We call it Sensei Stacks. And the idea was we wanted to be able to take and have kind of a Photoshop style editing. I don't know why it's not loading here. Let's go back here. Is this working? We might have to skip it if it's not going to load. I feel like I'm going to run out of time.
Yeah, you got 10.
10 minutes? All right. Just sit here and wait for this for 10 minutes. Yeah, we might skip that one since it's being temperamental. But I'll show you something better, hopefully. Basically, with that one, they were like, yeah, this is super powerful, but it's too complicated. Let's try this again. And so we created this tool here where we call Capsule. So each of the terms becomes a different capsule. So I can say, and I can just kind of, I'm adding these. So I say woman. I'm going to click on this one here. Here we're making query suggestions, and so you can just click on these. So I can say nurse. I can also isolate colors like this. And now we're starting to be able to take all of these different attributes, in this case keywords and color, and be able to search. And then you can go in, you can say, oh, I want to, how important is this? You can increase the weight. So that's just kind of a high-level example of some of the stuff that we do. Here, I'm going to say, this was another project that came out in the as a sneak for Adobe Max, and this was a researcher, and the idea was that we just want to use words and shapes to be able to describe an image for search. And so here I'm saying woman. Or now I say woman. If any of you are designers, they're like, when do I get this? And the answer is it's actually coming up. So yeah, a lot of the times you're taking and you're kind of making sketches. Like that roughly what you want is your layout, and you're able to now just use these different shapes. We can kind of move things around. Let's try to move the backpack over here just to show you that it's real. Yeah, and the backpack's on the right now. Hey. You guys are too generous. You're too generous. I'm here one night only. This is kind of more of an example of once again, we kind of, the research create something super raw. We create something that's kind of more refined, and then the product team makes it so like anybody can use it. So it's really simple. In this case, I'm searching a dog. I'm just going to put the dog over here on the left. Say woman. Put her on the right. Yeah, so we got the dog on the left, the women on the right. Let's switch it up just so you can tell it's real. You can do all kinds of weird things. You can make it go diagonal, and it actually works. This is actually really interesting. This is what we call a heat map, and so you can see where in the image we think the dog is and where the woman is in the image. Let's go ahead and put this here. And now the dog's on the other side. So once again, just we're searching across 60 million images in this case. It's happening really fast, right? But once again, we're able to find the right image for based on very specific attributes that you normally wouldn't be able to find. This is pose prediction. This is a new project that we're working on. In this case, you're able to now find people in lotus pose. So you upload an image, we could predict the pose of the person, and then you match it. So you could take a picture of yourself doing some things, and then be able to upload that, and then be able to get content that matches it. Oh yeah, so this is the project that changed my life. A lot of the ones that I've been showing you are great, but you need to know the tools. And so what we wanted to do was use natural language to be able to access AI on the back end. So as I use different words, we automatically bind those to different attributes. So I have to do this voice. I'm a little out of breath, so hold on. Okay. Find photos of an office. So then, that's the base query, and we can just build on top of that. Increase diversity. So the first one was a keyword and a filter. The second is we're using word to vec to kind of describe a higher level concept. More diversity. And now we're starting to get pretty diverse pictures of people in an office. Add a woman. And then now I'm going to use Concept Canvas, the thing I showed you before with the shapes. Move the woman to the right. And again, now we're, the women are on the right. Similar composition. And I'll pick this one. Composite samples. Composite sample. And this is, we kind of simulated this, but we're actually using real tools. And so we're using a feature that we call Deep Cutout. It's inside of Photoshop as under selection as subject, and we automatically pick out the most salient object in the image and mask that. And here we're kind of picking some complementary backgrounds that would suit these other attributes of a woman in an office. And then we do this composite. And then in this example, you can download the PSD. So I was talking like a robot in that previous example, but you can make it more conversational. Can you find me photos of a man at a cafe? I wanted it to work. Hold it. Find me photos of a cafe. Add a man. More coffee. Right? Add a laptop. Replace man with woman. And so all of these other attributes of the laptop and everything are still available to this. And you can go back, you can replace or remove anything. Like say, where are we going to put them? Replace cafe with park? Or hotel? I don't know. Hotel could be risque. Yeah, I don't know if that works. Revert. One of the first things we did was add revert and undo. Revert. Anyways, that's kind of a quick example. I mean, these are the goal behind this project wasn't to talk to your computer, which is kind of the gimmick, I think, but people really like it. Really, we wanted to enable you to have, complex, find a photo of a man find a photo of a woman and a dog on a beach. So the way we do it now, let's say, replace beach with forest, is all keyword based. And more snow. More snow. So then you could kind of pick one. Find similar. The goal was really to be able to take these complex queries and be able to not just use keyword matching. And so here we're doing some keyword, we're doing some word to vec, we're doing a similarity search, was part of the clustering that we showed earlier. But just with a couple words, I'm able to find these women and a dog in the snow, which is cool. We're almost done. I'm only at 11% battery, so time's a ticking. This is the banana challenge, as we call it. The problem is we got about almost 500,000 banana pictures, and they're all pretty similar. What we did was work with visual similarity again to automatically cluster these based on attributes. And so here, we've got kind of on the left, kind of a selection of bananas. We got banana smoothies. I'm going to stay away from the women on the bananas for reasons. And even banana bread. So banana bread seems pretty safe. Let's go there. And then within this, we create another set of visual similarity. What's going on there? Try again. We'll do this one. There we go. And then this is, once again, has similarity. And then these can be defined based on the content, the color, the composition. the count, and then we had an intern project for texture, which is kind of iffy. But just once again, the ability to sort through 500,000 pictures of bananas and be able to find just the right one. And then I think within these I can do some other stuff. And then here I go directly to stock. We got 2 more. We're almost done. Oh yeah. So he's like, all your demos are about images and videos. We talked about this at lunch. So I included one on text. And so in this one, we're reading different articles. So let's say sports. So it's taking this article from WikiQA, and then you can ask it questions. I'm just going to use the stock one here. What's the most known sports in America? And it's actually going to be looking at this content, analyzing the content, and then deriving the answer from the content. And this is real. It's not like so what do we got here? Football, baseball, basketball, and ice hockey. Well, that's cool. And then, we do quite a bit of work around text, a lot of it around summarization of documents, intelligently summarizing documents. We're doing some work around automatically translation of the auto tags. And so you can say, I want my auto tags in French, for example, and we'll output those in French so you don't have to go through a translation process. I think we're done.